In this lesson, we are going to talk about our linear programming problems, in which we are going to isolate and focus on the graphing portion. In the next assignment or two, you will get word problems that will be attached to these inequalities and these objective functions. But for now, we're only going to focus on graphing. So you'll remember that you just learned about graphing inequalities in standard form and slope-intercept form. We're mostly going to deal with standard form. So before you begin, make sure you have at least 3 different colored pens or pencils with you. We are going to graph each inequality, making sure to shade every time. Once our completed graph, we will have what we call a feasible region. From that feasible region, we are going to be able to test the corner points of that region to maximize the objective function. Let's get started on the graphing portion. I'm going to choose a red color. And when I graph, I like to circle the inequality that I'm graphing. If you remember your graphing skills, x greater than or equal to 0, this is a vertical line because all of the x values have to be 0. And no matter where I go on this y-axis, the x value is 0. So the line just looks like it covers up the y-axis. The inequality is all the x values greater than or equal to 0. So the greater than, my x values that are greater than 0 are to the right of the line. Therefore, I will shade nice straight lines like this off to the right. Now I'm going to pick a different color so we can color our y greater than or equal to 0. You can make a note that when it's just x, it's a vertical line. When it's the y, it is a horizontal line. So this line will cover up the x-axis because its y is greater than or equal to 0. And the y values that are bigger than 0 are above the y-axis. And you'll notice we have our first overlapping in quadrant 1. Pick your third color. This is our standard form inequality, where you can look back on that poster if you forget how to find the x and the y-intercept. To find the x-intercept, we take the c, the number out front, that's a 6 in our case, and divide it by a. Well, there's no number actually there. We always know that that is a 1. So the x-intercept is at 6, meaning along the x-axis, I'm going to count to the right 6 spots. 5, 6. That is where I make the x-intercept. It's along the x-axis. To find the y-intercept, that's going to take our c, our 6, divided by the number in front of the y. Well, if there isn't an actual number there, we know that that's a 1. And the y-intercept is also 6. So I'm going to count on the y-axis, 1, 2, 3, 4, 5, 6, and plot my point on the y-axis. Now, if you have a ruler, you can connect those 2 points. I don't have a ruler, but I do have this lovely tool to connect them and make it as straight as possible. Now I'll just trace it with my purple pen. To shade, remember that all we have to do is pick the point 0, 0. We're either going to shade on below the line or above the line. We got a 50-50 shot. If I pick the point 0, 0 and plug that in for x, that leaves me with 0 on the left side, less than or equal to 6. And since that is a true statement, we shade towards the 0, 0. If it were a false statement, we would be shading away, which would be on the other side of the line. Now you can choose one of your colors to highlight our shaded region, but we're looking for where all three colors, red, blue, and purple, where they all overlap, and that is this triangle region right here. This is the feasible region that comes from creating this graph. I'm going to erase my work on the right here because we have one more step to do. We need to identify our corner points so that we can test them. Well, the corner points, it happens at each corner of the triangle. So if we identify those points, we have 0, 0, 6, 0, and this top point up here is 0, 6. We're going to test them in this objective function. So if I want to maximize, that means I can eliminate 0, 0, because 0, 0 will not give me a maximum output. I'm going to start by testing the point 0, 6 by plugging it into this objective function, p equals 2x plus y. If my x were 0, my y were 6, I'm plugging in the 6 for the y. 2 times 0 is 0 plus 6 equals 6. Now let's test the other point that we have. 6, 0. Again, these points came from the feasible region. So to test that, I'm plugging in the 6 for the x value and the 0 in for the y. 2 times 6 is 12 plus 0 is 12. Which output gives me the maximum? 12 is the higher number, therefore this is our maximum output. You have what you need to finish this sheet. Remember to reference graphing in standard form poster from a previous assignment in this module if you need more help on the graphing.